Okay, so from 5 to 10, the rate at which vehicles arrive at a certain toll plaza is given by this equation, where T is the number of hours after 5 a.m. and A is measured in vehicles per hour. Traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. Write but do not evaluate an integral expression that gives the total number of vehicles that arrive at the toll plaza from 6 a.m. to 10 a.m. So, and they very nicely gave you T equals 1 and T equals 5 there. So, for this one, we've got integral from 1 to 5 of A of T dt, and you just have to do that in your calculator. So, oh, yeah, it does. Why does it tell you not to evaluate? It's weird.
So, do you have to do AT dt, or could you put like the actual equation?
You can put the equation. It's fine. If you put the equation, that is good. But this is all you have to write. No equal sign there. That's strange that they did not ask you to evaluate that.
Yeah, I thought I was going to get it wrong because it was so simple.
Yeah.
I might have got it wrong. So I might have
Yeah,
got
that's it.
6.
Okay, so we got, that's got to be a 1-point problem, I would think. So, yeah, all you had to know was that was integrating, that to get from the rate to the number that you were integrating. So, A, super easy. We're starting off good here. All right, find the average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza from 6 a.m. to 10 a.m. So, we're finding average value of what? The rate. So, it's A of T. So, we're going to do, and it's from 1 to 5, so we'll do 1 over 5 minus 1, or you could just write 1/4. Integral from 1 to 5 of A of T dt. And then this one we do have to evaluate. So let's do that in the calculator. And as we're doing this, do write this down because I'm going to give you a free response grade on it. This is going to be a grade like in the free response section. So we're going to do them together. So as long as you're following along.
Easy points.
Easy points. So 450. Second. Okay. Have I got that in right? Yep. Okay. All right. So I've got 1/4 integral of y1 of x, comma x, comma 1, comma 5. And so 375.537.
No, I got 375. I moved.
And it doesn't ask for units there. It actually gives you the units as vehicles per hour.
Well, units anyways, so I was not losing.
Yeah.
I was just like,
So, both of these are pretty easy. They make me a little nervous that something's wrong, but I think we're good. Because it's the average value of the rate. A is the rate. So we don't need to do anything different or special there. Alright, so for C, is the rate at which vehicles arrive at the toll plaza at 6 a.m. increasing or decreasing? Give a reason for your answer. Okay, how are we going to know?
You have to take the derivative of AT, see if it's positive or negative.
All you have to write for this is A prime of 6. A is the derivative. A is the rate.
You mean 1?
Oh, I'm sorry. Yes, 1. A prime of 1. And that's all you have to write. And then we'll write our answer and make our conclusion. So, in the calculator, the quickest way to do this is do F3, differentiate y1 of x, comma x, and then do such that x equals 1. I'll plug it in for you. So you may have like taken the derivative and wrote that down and then plugged in 1. That's fine. But this is like bare minimum of what you got to do. 148.947.
Got positive numbers.
And then, so that's probably a point here. And then you would say since a prime of 1 is greater than 0, the rate at which vehicles arrive at the toll plaza at the
Did you just say since
toll
a
plaza.
prime of 1 is greater than 0, a of 2? Do you increase it
Probably,
at time t equals 1?
I think that would be okay. You have to have the at time t equals 1.
Yeah.
But I think so. Rate at which vehicles arrive at the toll plaza at 6 a.m. is increasing.
I think I put that.
Yeah, and if you, I think you would be okay with just saying A of t instead of saying the rate at which vehicles are arriving. Yeah. So I think it would be okay.
Oh, I did that on like, it was a part B, but I did it in part A section.
Yeah.
Section, and I was like,
That's what I did too.
Yeah. 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 Be careful. Yeah. All right. So 1, I think, is a point. 2 is probably 2 points. 1 for the setup, 1 for the answer. C, I would think is 2 points. A point for a prime of 1 and a point for the explanation, which means D would be a 4 point if that's the case. But if you get the first 3, that's 5 points right there, which is a decent start on this. So let's see what D says. All right, so a line forms whenever A of t is greater than or equal to 400. The number of vehicles in line at time t for A is less than or equal to t less than or equal to 4 is given by this, where A is the time when a line first begins to form. So the nearest whole number, find the greatest number of vehicles in the line at the toll plaza in the time interval from A to 4. Justify your answer. So when is the line going to begin to form?
At 400.
Whenever A of t equals 400, right? So, and then the number of people in line is given by n of t equals a to the integral from a to t of this expression right here. So, we need to figure out when, first thing we need to do is figure out when A of t equals 400, because that's going to give us our lowercase a value.
Just put it A of t equals 400, put it in solve.
Yeah, yes, I think, let's try that. It should work with solve. So y1 of x equals 400, comma x. So the problem with this is I think that 1.6129 is probably going to be right, but because this is trig, it gives like repetitive answers. So just to be sure, I'm going to go to the y equals. I'm going to put 400 here for the y2, and I'm going to go to the window and I know I need to go, well, my Y max needs to be at least 450. I'm going to make it 500. And then I'm going to graph it. Okay, so that gives us a pretty good look there. And then we're going to do intersection, first curve, second curve, and then lower bound. It's down here, upper bound up here. See, that's a different number than it gave you on solve. I think.
That's exactly what I did.
Yeah. Okay, so A is going to be 1.46937.
I skipped it, but I came back to it whenever I finished.
All right, I'm going to store that as A in my calculator. So that is our A value. So that tells us that N of T is going to be the integral from, well, we really already have this. We know what the A value is here. You can write 1.46937 if you want, but now that you've written down the A equals that value, you can use the A instead of writing the value. All right, so if we take the derivative of this, because what we're looking for is when the number of, this N gives you number of vehicles in line. So, oh yeah, it needs to be an X right there. So,
We have read that differently considered X, or just kept assuming that.
T's so it has to, the T right here cannot match the variable that's here. So we really should just rewrite it like it is here. And then we want to look at the derivative, set that equal to 0, find the critical points, tell where we have a maximum is what we want to do for this. So if I take the derivative of this integral expression, what will I get?
A of T minus 400 minus the expression of A of T.
It's just A of T minus 400. So you want to plug in the T right here. Then you would multiply by the derivative of T, but the derivative of T would just be 1. So this is your derivative. So you're going to set this equal to 0, right? So A of T equals 400 is where you're going to find your critical point. We just did that. It's at A equals 1.46937. And there was another point, right? We didn't find it this time. Let's go back to the graph. We also had this point right here. So if we go find that intersection, we get 3.59771. Actually, I might should use the T right here. Alright, and then, let's see, this ends at what, 5? Yeah, we only use this equation from 5 to 10, which is 0. 0 to 5. So we put 5 right here. So, so if we're thinking about n prime of t, so that is a of t minus 400. Is n prime going to be positive or negative when we're on this section right here? It's going to be negative because a of t is less than 400. So whenever you do a of t minus the 400, because right here is our line for 400. So you're going to get a negative here. You will get a positive right here because a of t is greater than 400. And then you'll do a negative right here because it drops back down below. So, where could we have a maximum? It could be right here. This is definitely a relative maximum. Where else could it possibly be a maximum? At possibly 0. But we know n of 0. What was n of 0? How many cars were in line at 0? 0. Right? So, it's not going to be that, right? Do we have to find... Yeah, we have to find the greatest number. So, we're going to then do n of 3.59771, which is going to be the integral from a to 3.59771 of a of t minus 400 dt, which, if we do that, y1 of x, comma, x, oh wait, I'm sorry, y1 of x minus 400, comma, x, comma, a, comma, 3.59771. So we'll get 71.2541. And to the nearest whole number, find the greatest number of vehicles in line. I would say since n of 0 is less than n of 3.59771, the greatest number of vehicles in line occurs at t equals 3.59771 and is set about, let's say about, yeah, we could, 71 cars. I think you would round down on that. Some have a policy of like always rounding up because if you got 0.25 car, you count it as a whole car. But I think you would round it. And if you, or it may be one of those things where they would take even one. So that one, probably a point for A. There's a couple points in here somewhere. Maybe a point for, probably a point for just finding that derivative. And then a point for either like, probably a point for getting those places where it equals 400, and then a point for the answer, I think. I'm not 100% sure where the points would be in the middle here, but point for the answer for sure, point for A, lowercase a, I'd say for sure. There's 2 points somewhere here in the middle, I would say. So, how'd you guys do on that one? A, B, and C, good. D.
I might have like a point or two, maybe 3.
Yeah. Did anybody find at least A on?
Yeah.
Yeah.
I found A and
Yeah.
B.
So,
I know that.
so possibly some points there. Yeah. Yeah. Right. Yeah. Yeah. I think the calculator slows you down rather than speeds you up. You would think it would be the opposite, but I think it actually makes you slower. Ethan, are you writing these down? This is a grade.
I got some of it written down.
Write it all down. All you have to do is copy it off the board. Don't be like the Math 1 kids that turn in their warm-ups half done, even though we wrote everything down together. Even though we're moving on, you're going to have to go back and get that one. You haven't got everything. All right, so that was number 1. Let's see. Well, I'll probably mess this up. Oh, I'm going to do. Oh, yeah, I messed this up. Alright, let's just do this. Alright, Ethan. Write some of this down this time. These are free points right here. We might have to go back and fix them tomorrow. I don't know. Oh, I need to save this too, so I've got to save. It's something you're definitely going to integrate a bunch on. So, you may or may not even have to do that. Let's see. Let's see. I'm going to save this. Alright. Okay, let's see what we got here. Alright, so we got F and G. They give us the equations for both. The graphs of F and G shown in the figure above intersect at -2 and x equals b, where b is greater than 0. Find the area of the region enclosed by the graphs of F and G. So we're going to put both of these into the calculator. So we will have natural log of x plus 3 is all we got for that one. And then we've got x to the 4th plus 2x to the 3rd. And that is it. Okay. So the first thing we have to do, they tell us they intersect at -2. We've got to find this other intersection point. So we're going to go to the graph. Yeah. And I think I need to go to, it's like zoom 6 here. Yeah, that's better. Yeah, zoom 6 is, alright, so intersection, first curve, second curve, lower bound. Alright, so there's our intersection. So there's a few ways you could write this. What I would probably do is I would probably do this, f of x equals g of x, and then I would say x equals 0.781975. Therefore, capital B equals 0.781975. You could also, if you only just write down like capital B equals 0.781975, I would probably say something about them intersecting just to be extra safe. You might be okay just writing down the number. I'm not certain, but it wouldn't hurt to say something. Because when you do stuff in the calculator, you're supposed to show how you got that from the calculator. So it wouldn't hurt to say intersection of F and G, even though it does tell you that. So I don't think you have to do that, but it couldn't hurt. So we found B, and we need the area enclosed for the region. So all you have to do for this is the integral from -2 to capital B of the top function minus the bottom function. The top function is f of x. The bottom function is g of x. We'll put a dx over here. So, yeah, it's just top minus bottom. You do not square anything for this. I know, Logan, you were saying something about like an absolute value.
Well, I put it all in a different, I put it in 4 different quadrants. I feel like I still got it right.
Yeah, you could probably still get it right that way.
Because I took the absolute value of the one that goes below the
Right.
curve, and then I took the section that goes above the curve from -2 to 0, added those together, and then took 0 to that point for the top one, and then subtracted the bottom from that.
Yeah, I think you can still get it right, because that is correct. But it will sort of like take care of itself if you just do top minus bottom, because where you're subtracting, but this area right here is negative, that minus, the negative kind of cancels out on that part to just do it for you. So you can just do it this way, and if you do, we're going to do integrate y1 of x minus y2 of x, comma, x, comma, -2, comma. Oh, I should have stored that value, but I didn't. I think it'll be okay. I kept 781,975. And 3.60355. I think probably a point for finding B, a point for setting up the integral, and a point for the answer on that would be my guess. Even though we'll see what they give points on. That was part A. We'll have to see for the rest of it because we still got B, C, and D. So I might be wrong. It might only be 2 points. Okay. Then for B, we've got from -2 to B, let h of x be the vertical distance between the graphs. Is h increasing or decreasing at -0.5? Give a reason for your answer. So for this function, f of x is always above g of x on the interval that we're looking at, so you don't have to use absolute value bars or anything here. So you would just say h of x equals f of x minus g of x. And so we want to know, is h increasing or decreasing at x equals -0.5? So you can kind of, well, it's a little hard to tell. It's pretty close. -0.5 is right here. This part right here is increasing, but so is this. So it's a little hard to tell if that. It looks like the distance is about the same from like right here to right here, you know. So if we want to know if something's increasing or decreasing, we look at its derivative. So we would find h prime of x, which would just be f prime of x minus g prime of x. And we only care about 1 point, so we're just going to plug in negative 0.5. So h prime of negative 0.5 is going to be f prime of negative 0.5 minus g prime of negative 0.5. And we're going to do that in the calculator. So we need to do the derivative of y1 of x, comma x, such that x equals negative 0.5. I'm going to hit enter and go ahead and get that number. You get point, I'm going to write down 0.4. That is f prime of negative 0.5. And then if I do g prime, it's really the exact same thing except for I need y2. So I'm just going to change that to a y2. And that is 1. So you would get negative 0.6. And if you do that all in one step, that's fine. I just get mixed up sometimes with parentheses and want to do them separately. Alright, so since the derivative of h is negative, what would we say about h? Decreasing. So since h prime of negative 0.5 is less than 0, h is decreasing at x equals negative 0.5. Yes. Right. Right. If you explained it well, I think you can still get full credit for that. So if you have the numbers there where you've taken the derivative, you've plugged in negative 0.5, and you're showing that g is changing at a rate of 1, I think if you explain it well, you can still get full credit on that. That would be another option. I think that will be fine. I think that will work. Mm-hmm. Yes. Okay. All right. C, the region enclosed by the graphs of f and g is the base of a solid. Cross sections of the solid are taken perpendicular to the x-axis or squares. Find the volume of the solid. This is a very straightforward one. So that length, that S here is just top minus bottom. So S, you don't have to write every step of this. I think all you have to write is the answer. But S would just be f of x minus g of x. Your area for a square is s squared. And so it is perpendicular to the x-axis, yes. So your area formula would be f of x minus g of x squared. Make sure the square's on the outside of the parentheses there. And then you just have to integrate from negative 2 to b of f of x minus g of x squared, like that. And you have to find it, right? Yes. So we would integrate y1 of x minus y2 of x, comma, x, comma, negative 2, comma, what was b? B was 0.781976. 0.75. It would have been better if I'd stored that as D, but I did not. And so, oh, I didn't square it. So I paused there because I realized that that's the same thing I got for part A, which lets me know I did it wrong. So I need a set of parentheses right here around my y1 minus y2, and I need to square it. I forgot to square. And then hopefully this will be our answer. So, and that equals 5.3401. So it's really straightforward. Like, so far, nothing about this has really been too difficult, but we haven't done D yet. So, if you remember how to do all of those, I realize calculus is a huge class where you may or may not remember all of these things. But as far as difficulty level, if you understand the concepts, this is pretty low so far. All right, then D. A vertical line in an XY plane travels from left to right along the base of the solid described in part C. The vertical line is moving at a constant rate of 7 units per second. Find the rate of change of the area of the cross-section above the vertical line with respect to time when the vertical line is at position x equals -0.5. Here is why they made A, B, and C so easy, because D's crazy. This is one that I'm going to have to think about for a minute. So,
I got my answer up on the board for D. My answer's already up there on the board for D.
Oh, it looks exactly like this. Yeah. All right, let's see. Vertical line from left to right. Vertical line is rate of change. Area of the cross section above the vertical line with respect to time. And the vertical line is at a position. All right. When it said, I don't like that phrase cross section. Above the vertical line. All right, rate of change varies. So the area is, so the area of the cross section. I don't like that they called that the cross section, but that's the area of the cross section. It's just going to be the integral from I'm going to call it C because that's a letter that has not been used in the problem so far, to B of f of x minus g of x. Yes. So that, actually let me give that, I'm going to let that be A. I've already used A, but. So area of the cross section, I'm going to call it A, equals this. So this gives us the area. So if we take the derivative of this with respect to t, is what we're doing. So this is a related rates with an integral, which I've never seen before ever, and I've done almost all of the FRQ questions from the last 20 years. It's not going to be high, no. Not many people are going to get this. But you're going to do dA dt equals, we have to take the derivative,
How can you know that?
Okay. F prime of x minus g prime of x evaluated from C to B. But where do I put?
You just accept fate and move on.
I don't want to give up.
I went back and did another.
Because you need d C dt. Okay, let's try this. Okay, let's see if I can make it work this way. Alright. When we integrate f of x minus g of x, we will get, I'm going to call it capital F of b minus capital F of c. Okay? So, hold on, I haven't. This is still A. Alright, A equals this. Capital F being, we might even want to say capital F prime of x equals F of x over here. So they know that our capital F is our integral of our lowercase f. So if we take the derivative of this, capital F of b is a number. Because capital F of b is an actual number. So it's going to be 0. Minus lowercase f of c dc dt. I have very low confidence in this correctness. I'm not so sure about this f of b being 0 right here. But it might be. Oh no! Oh no! Okay. Oh no! I gotta go back. Okay. Let's go back. I've got to go back. All right. So, oh gosh. Yeah. You probably should maybe just wait till I check with the Facebook group before you write anything in pen here. Let's see. So it's not just F. It's F minus G, which is H. Well, we called f of x minus, we called this H earlier. Okay, we can break this apart. C to B of f of x dx minus C to B of g of x dx. We can break it apart because it's just subtraction. Okay, so let's also say that capital G prime of x equals g of x. So this will give us capital F of B minus capital F of C minus capital G of B minus capital G of C. Oh my, okay. So if we take the derivative here, derivative of f of b is 0. Derivative of f of capital F of c is lowercase f of c dc dt. Because c is a variable. Minus derivative of g of b is 0 because that's a number. Lowercase g of c dc dt. Which is going to be negative f of c dc dt plus g of c dc dt. dc dt. C is your point that's moving from -2 to B, and the point is moving at a constant rate of 7 units per second. So dc dt is 7, and we're plugging in 0.5. I think we might have actually done this. Maybe. Yeah. I'm too scared to do that. So let's do x equals -0.5. And so we'd have negative f of -0.5 times 7 plus g of -0.5 times 7. And we're going to type that into the calculator and see if we can find something. So negative y1 of -0.5 times 7 minus y2. I'm sorry, that should be a plus right there. Plus y2 of -0.5 times 7. It's going to give us -7.72654. It would make sense that that's negative because that area should be decreasing, right? Because as that point moves to the right, it is moving to the right, isn't it?
Yes, from left to right.
Yes. From left to right, yeah. So as that point moves from left to right, the area above that line should be positive. So, should be decreasing. So, at t equals -0.5, or I'm sorry, at x equals the area of the cross section is decreasing at a rate of 7.72654 units squared per second. We need to have a party if I got that right. Because that question's crazy. A, B, and C are easy for that type of problem. I'm not saying it's easy to remember all of calculus, but their difficulty level for those types of problems are low. They're really straightforward. But D is crazy. This is the one somebody was paid just to come up with something they didn't think anybody would figure out. And I can't wait to see if I actually got it right, because I feel like I might have got it right. Maybe. There's a chance that that is right, but we'll see. We'll see. Because that's a crazy problem. All right, we're going to do one more and we're going to quit for today. All right, let's do 3. Okay. F is a differentiable function with f of 4 equals 3 on the interval from 0 to 7, the graph of f prime. The derivative of f consists of a semicircle, 2 line segments as shown above. We're supposed to find f of 0 and f of 5. So, they give us f of 4. We know f of 4. So, if we're finding f of 0, it is going to be f of 4 plus the integral from 4 to 0 of f prime of x dx. They don't tell us if we don't know f of 0 here. So we cannot do that. We have to go from f of 4, which is the point that we know. And so really, because this integral right here is backwards, you've got 4 to 0 since it's backwards, we really could write this f of 4 minus the integral from 0 to 4, f prime of x dx. And so that would be, f of 4 is 3, they tell us that. And then we want to do area from 0 to 4, which is just the area of that semicircle. So it's going to be, which I really don't need that bracket for. So it would be pi times 2 squared divided by 2. So we would get, for f of 0, we would get 3 minus 2 pi for that. And then for f of 5, we would again start from f of 4, and we would need to add the integral from 4 to 5 of f prime of x dx. F of 4 is still 3. From 4 to 5 is just this tiny little triangle here, and it just has an area of 1/2, I believe. So we'll get f of 5 is 3.5. Does any of you think you got that? Eli got it? I feel like this is something I did not cover well enough this time.
I got the area of the thing, but I got it for...
You got it for the wrong part, yeah. I feel like I should improve the way that I cover this, because...
At first I couldn't figure out how to do it all.
Yeah. I need to probably improve what we do for that, because it's not a terribly difficult question, but I feel like it's something I slacked on a little bit this year that we could do better on in the future, hopefully. So I feel pretty confident about that. Hope I'm right anyway. B, x coordinates of all points of inflection on the graph of f for 0 to 7 justify your answer. Okay, so points of inflection are going to be where concavity changes, which means second derivative changes. But are we looking at the second derivative? We're not. We're looking at the first derivative. So what happens to the first derivative when we have a concavity change? Increasing to decreasing, or decreasing to increasing. So we would say here f has points of inflection you got one right here at 2, and then the other one here at 6. Points of inflection at x equals 2 and x equals 6, because f prime of x changes from increasing to decreasing, or vice versa.
I know I got that right because I said vice versa. That was the explanation.
At these points. That won't work. Changes signs. Now, if you put 2 and 6, if it's a 2-point question, you'll probably get a point for getting the correct points. But changes signs would show a maximum or minimum. That is fine as long as you also mentioned f prime. If you only mentioned f double prime, it does not count because you don't have a graph of f double prime. So like if at the end of this, you definitely don't need to, but if at the end of this you wrote which means f double prime of x changes signs, that would be fine. But if you only put because of f double prime, it will not count for your explanation because you aren't looking at f double prime. So you have to tell them from what you're looking at how you know f double prime changes signs. So it's fine to mention it as long as you also mention f prime. All right. C. G is given by f of x minus x. On what intervals, if any, is G decreasing for 0 to 7? Show the analysis that leads to your answer. So if we want to know if G is increasing or decreasing, what have we got to look at? First derivative, right? So we're going to take G prime of x is going to equal f prime of x minus 1. Possibly, depending on how they split the points here. So, if we want to know if something's increasing or decreasing, we're going to set that derivative equal to 0, right? And so we're looking for where f prime of x equals 1. So, gotta give the exact points. Alright, so there's one that's pretty easy to find. And that would be at x equals 5. Right? Because that should equal 1 there, I believe. Yeah. And 7. So we got x equals 5. We also got x equals 7. Those are good points. So, never mind. It's only positive 1. I'm thinking positive and negative 1. We're good here. Just 5 and 7. We're good. I was thinking positive and negative 1, which meant I was going to have to figure out what these points right here were, which was not going to, it's possible, but was not going to be easy. It's got to equal 1. At 0, f prime equals 0. So we got 5 and 7. Okay, so we're doing good here. So now we need to make a sign line for G prime of x. And so on that sign line we will put 0, we will put 5, and we will put 7. 0 and 7 were our endpoints anyway. 5 is the place where f prime equals 1. So for 0 to 5, if I plug in f prime of x, if I plug in a number here, so I'm looking at f prime of x minus 1, am I going to get a positive or a negative number? Negative, because this is below the x-axis here. It's too small to make it a positive. So we're going to have a negative right here. From 5 to 7, if I plug in one of those numbers, I'll get a positive. So we would say that G of x is decreasing for 0 less than x less than 5 because G prime of x is less than 0 for that interval. I think it's probably okay either way. My calculus teacher always taught me for increasing or decreasing. It was not to use the or equal to. Some books do though, so I think it really doesn't matter which one you put. I hope that's right. Got this down, Ethan? Write it down. You are not failing this class. Do not be the first kid who has ever failed calculus. Write it down. You're not failing right now. All you gotta do is turn stuff in. I'm giving it to you. I'm gonna make you do it tomorrow when everybody else is gone.
Tomorrow, you have to do them on your own.
Okay. Alright, and let's see what D has here for us. That's not too terrible. Yeah, I think that's not too terrible. For the function g, defined in part C, find the absolute minimum value on the interval from 0 to 7. Justify your answer. So, gosh, alright, so I'm pretty sure all you have to do for this is explain g prime of or g of x decrease. I mean, we've already explained it on part C, but I'm going to restate it just in case. G of x decreases on 0 to 5 because g prime of x is less than 0, and g of x increases for on 5 to 7 because g prime of x is greater than 0. Therefore, g of x must have an absolute minimum at x equals 5. And it does ask you to find that minimum, so you've got to find the y value. So you would do g of 5, which would equal f of 5 minus 5. And you found f of 5 in part A, so that was 3.5 minus 5, which is going to be negative 1.5. So I would just put minimum value of g of x on 0 less than or equal to x less than or equal to 7. I feel like I probably didn't teach part A very well, but that one was not, I don't think 3 was too bad.
Before that, like the night before, I
Uh-huh.
watched a video of how to do it,
Uh-huh.
but then I struggled to do it.
Yeah, I think that's something that I need to do a better job of teaching next time.